Welcome to Whispering Atom, where the mysteries of the universe unfold like gentle waves on a quiet shore. I'm here with you tonight to explore one of nature's most beautiful secrets, one that's been hiding in plain sight your entire life. As you settle in, let me know where in the world and at what time you're watching. Are you tucked beneath soft blankets in a cozy bedroom, perhaps with the gentle glow of a bedside lamp? Or maybe you're in a quiet living room, the day's activities finally coming to rest? Wherever you are, you're exactly where you need to be. Tonight, we're going to discover something remarkable about time itself, something that connects the beating of your heart to the vast dance of galaxies, something that makes your head just a tiny bit older than your feet. But don't worry about understanding everything at once. Let the ideas wash over you like a warm tide. Some will settle into your mind immediately. Others will drift and float until they find their perfect place. Now, get comfortable. Adjust your pillow, pull that blanket a little higher, and let your breathing slow to match the gentle rhythm of discovery. Take a slow breath in, and as you exhale, let yourself sink deeper into this moment. We're about to embark on a journey through time itself, but it's a journey measured not in years or days, but in the quiet heartbeats between one moment and the next. Are you ready? Then let's begin this gentle exploration of gravity's most tender secret. Right now, as you rest there listening to these words, something extraordinary is happening to you. It's so subtle that you've never noticed it, so gentle that it requires the most sensitive instrument science has ever created to detect. But it's real, and it's been happening every single moment of your life. Your head is aging faster than your feet. I know this sounds impossible, perhaps even a little strange, but stay with me as we explore this together. Imagine, if you will, that time is not the rigid, unchanging river we often think it is. Instead, picture time as something more like honey, flowing at different speeds depending on where you are and what's around you. Sometimes it flows quickly, sometimes slowly, but always it flows. The secret lies in gravity, that invisible force that keeps your feet planted firmly on the ground and draws everything toward the center of the earth. You've lived with gravity your entire life, felt it in every step, every breath, every moment when you've dropped something and watched it fall. But gravity does more than just pull things downward. It also pulls at time itself, stretching it, slowing it, making it flow like thick syrup in a cosmic dance that's been choreographed by the very fabric of space and time. Einstein discovered this over a century ago, this strange relationship between gravity and time. He called it time dilation, though that might sound like a cold, scientific term for something that's actually quite beautiful. Think of it this way. The stronger gravity's pull, the slower time moves. And since gravity gets slightly weaker the higher you go, time flows just a little bit faster at your head than it does at your feet. The difference is incredibly small. So small that if you lived for 1 billion years, your head would only age about 1.5 minutes more than your feet. But in the quiet language of physics, in the whispered conversations between atoms and the gentle mathematics that govern our universe, this tiny difference speaks volumes about the nature of reality itself. Let's imagine you're standing in a quiet meadow on a warm afternoon. The sun is filtering through the leaves of a nearby oak tree, casting gentle shadows that dance with the breeze. You're perfectly still, just breathing, just being. In this moment, every atom in your body is experiencing time slightly differently. The atoms in your hair, reaching just that little bit higher toward the sky, are moving through time at a pace that's ever so slightly faster than the atoms in your toes, which are closer to the Earth's center and feel gravity's pull just a little more strongly. This isn't something you can feel, not directly. Your body moves through time as one unified whole, your consciousness experiencing each moment as it comes. But if you could somehow speak to the atoms themselves, if you could listen to their quiet atomic whispers, you might hear them tell different stories about the passage of time. The atoms in your head might speak of moments that pass like gentle breezes, flowing just a tiny bit more freely. The atoms in your feet might describe time as having just a little more weight to it, like walking through air that's grown imperceptibly thicker. Neither is right or wrong. Neither is experiencing the true passage of time, because there is no such thing as a single, universal tick of the cosmic clock. This is one of the most profound insights that modern physics has given us. Time is not absolute. It's not a great metronome keeping perfect rhythm throughout the universe. Instead, time is personal, local, intimately connected to where you are and what's happening around you. It's as if each point in space carries its own gentle timekeeper, and these timekeepers, while staying in general harmony, each beat to their own slightly different rhythm. As you lie there now, this cosmic ballet continues around you and within you. The gravitational field of Earth, that invisible web of attraction that surrounds our planet, is not uniform. It's stronger at your feet and weaker at your head, creating what physicists call a gravitational gradient. This gradient is incredibly gentle, a slope in the fabric of spacetime that's so gradual you could never hope to feel it directly. But time feels it. Time responds to this gradient like a skilled dancer responding to music, flowing more slowly where gravity is stronger, flowing more quickly where gravity is weaker. And so, in this quiet moment, as you rest and listen, your head is taking tiny, infinitesimal steps into the future while your feet follow, just a heartbeat behind. Think about what this means for the story of your life. Every step you've ever taken, every time you stood up or sat down, every moment you've spent lying in bed or reaching toward the sky, you've been navigating not just through space, but through time itself. Your body has been a kind of time machine, with different parts of you traveling at different speeds through the temporal landscape. When you were a child, perhaps running through a playground, your head was already beginning its journey into the future, moving through time at a pace that was imperceptibly faster than your feet. As you grew taller, this difference became more pronounced, though still so small that only the most precise atomic clocks could detect it. Every growth spurt, every inch you gained, was also a step into a slightly different relationship with time itself. The water in your body, flowing through your circulatory system, carries with it this temporal complexity. Blood flowing up toward your brain moves into regions where time passes just a little more quickly. Blood flowing down toward your feet enters areas where time moves just a little more slowly. Your heart, that faithful timekeeper that has beaten billions of times throughout your life, is actually beating in a slightly different temporal rhythm at its top than at its bottom. This isn't something that affects your health or your daily life in any noticeable way. The human body is remarkably adaptable, and these tiny temporal differences are far too small to influence biological processes. But they're real, measurable, and they speak to a deeper truth about the universe we inhabit. Consider the air you're breathing right now. Each molecule of oxygen that enters your lungs carries with it the signature of its journey through time. The molecules that were floating at the level of your head just a moment ago were moving through time at a slightly different pace than those that were down at the level of your feet. They've all converged in your lungs, bringing with them their own tiny temporal histories. Even the light that illuminates your room, whether it's the soft glow of artificial lighting or the gentle radiance of moonlight streaming through a window, participates in this cosmic dance. Photons of light, traveling at their constant speed, still experience the effects of gravity's pull on time. Light traveling upward through Earth's gravitational field shifts to slightly higher frequencies, while light traveling downward shifts to slightly lower frequencies. This is called gravitational redshift, and it's another way that gravity whispers its secrets about the nature of time. The remarkable thing is that this has been happening everywhere, all the time, since the beginning of the universe. Every star, every planet, every grain of sand on every beach, every drop of water in every ocean participates in this gentle temporal dance. Gravity pulls at time wherever mass exists, creating a universe where time flows like a vast, invisible river with countless tributaries and currents. On our planet, this temporal landscape is shaped by the distribution of mass within the Earth itself. The molten iron core, the solid mantle, the continents and oceans all contribute to the gravitational field that influences the flow of time. Mountains create tiny temporal valleys where time moves just a little more slowly. Ocean trenches create temporal hills where time moves just a little more quickly. The entire Earth is a complex temporal sculpture, carved by the distribution of matter and energy. As you rest there, breathing quietly, you're experiencing this temporal landscape in the most intimate way possible. Your body is a living instrument for measuring time's subtle variations, though the measurements are far too small for you to consciously detect. Every atom in your body carries with it the story of its journey through time, and that story is slightly different depending on where in your body that atom resides. The calcium in your bones, the iron in your blood, the carbon in your muscles, the oxygen in your lungs. All of these elements are participating in this temporal symphony. They're all moving through time together, carrying your consciousness forward moment by moment, but each at their own slightly different pace. This is perhaps one of the most beautiful aspects of Einstein's discovery. It reveals that we're not just traveling through space as we move through our daily lives. We're also traveling through time, and we're doing so in a way that's intimately connected to the mass and energy around us. Every journey is a journey through space-time. Every moment is a moment in a four-dimensional dance that connects us to the deepest structures of reality. The implications of this discovery extend far beyond the small difference between your head and your feet. They touch on fundamental questions about the nature of existence itself. If time can flow at different rates in different places, what does this mean for our understanding of simultaneity? If two events happen at the same time in one reference frame, they might happen at different times in another reference frame. The universe becomes a place where the very concept of now becomes local, personal, relative. But for tonight, as you rest and listen, perhaps the most important thing to understand is simply this. You are part of a universe that is far more interconnected and far more beautiful than our everyday experience suggests. The force that keeps your feet on the ground is the same force that shapes the flow of time itself. The gravity that holds our planet in its orbit around the sun is the same gravity that makes your head age just a little bit faster than your feet. As we continue our gentle exploration tonight, we'll discover how scientists first realized this remarkable truth, how they measured something so subtle that it seems almost impossible to detect. We'll explore what this means for the world around us, from the tallest mountains to the deepest oceans, from the smallest atoms to the largest stars. But for now, just rest in this knowledge. You are a temporal being, living in a universe where time itself dances to the rhythm of gravity's gentle pull. Let this thought settle into your mind like a warm blanket. You are not just a collection of atoms and molecules moving through space. You are a conscious being experiencing the flow of time in all its subtle complexity, part of a cosmic ballet that has been dancing since the universe began. And in this moment, as you breathe quietly and let these ideas wash over you, you are participating in one of the most profound discoveries ever made about the nature of reality itself. The difference between your head and your feet is small, but it opens a window into the deep structure of the universe. It reminds us that even in our most ordinary moments, we are connected to the extraordinary. Even as we rest, even as we prepare for sleep, we are part of something vast and beautiful and mysterious. And that perhaps is the most comforting thought of all as we drift toward the gentle embrace of sleep, knowing that we are held not just by gravity, but by time itself in all its infinite, flowing complexity. Now, as you settle deeper into this gentle understanding of time's secret dance, let me tell you the story of how we came to discover this remarkable truth. It's a story that began with a quiet man who spent his days thinking about light, about motion, and about the fundamental nature of reality itself. His name was Albert Einstein, and his discovery would change forever how we understand the universe and our place within it. Picture, if you will, a young patent clerk in Switzerland in the early 1900s. The world around him was changing rapidly. Electric lights were replacing gas lamps. Automobiles were beginning to share the roads with horses, and the pace of life was accelerating in ways that previous generations could never have imagined. But in his small office, Albert Einstein was contemplating something that seemed utterly removed from the bustle of modern life: the relationship between space and time. Einstein had been troubled by a puzzle that had been bothering physicists for decades. Light, they had discovered, always travels at the same speed, no matter how fast you're moving when you measure it. This seemed impossible, contradictory to everything our intuition tells us about motion and speed. If you're driving a car and you throw a ball forward, the ball moves faster relative to the ground than it does relative to you. But light doesn't behave this way. No matter how fast you travel, light always appears to move at exactly the same speed. This realization led Einstein to a profound insight. If the speed of light is constant, then something else must be variable. And what he discovered was that space and time themselves are flexible, interconnected, and responsive to the presence of matter and energy. This was the birth of his theory of relativity, and it would revolutionize our understanding of the universe. In his special theory of relativity, published in 1905, Einstein showed that time passes differently for objects moving at different speeds. If you could travel at very high speeds, approaching the speed of light, time would slow down for you relative to someone standing still. This wasn't just a mathematical curiosity. It was a fundamental feature of reality itself. But Einstein didn't stop there. Over the next decade, he developed an even more profound insight. Gravity and acceleration are equivalent. If you're in a windowless room and you feel pressed against the floor, you can't tell whether you're standing on a planet's surface feeling the pull of gravity or whether you're in a spacecraft accelerating through space. This principle, called the equivalence principle, led Einstein to his general theory of relativity. In this new understanding, gravity isn't really a force in the traditional sense. Instead, it's a curvature in the fabric of space-time itself. Massive objects like planets and stars create dips and valleys in this fabric, and other objects move along the curved paths created by these distortions. It's like placing a bowling ball on a stretched rubber sheet. The ball creates a depression, and if you roll marbles nearby, they'll curve around the depression rather than traveling in straight lines. This was Einstein's quiet revolution, the recognition that space and time are not separate, fixed entities, but rather two aspects of a single, flexible fabric called spacetime. And this fabric responds to the presence of matter and energy by curving, stretching, and warping in ways that create what we experience as gravity. But here's where the story becomes even more beautiful and relevant to our gentle exploration tonight. Einstein realized that if gravity is really a curvature of space-time, then time itself must be affected by gravity. In regions where space-time is more curved, where gravity is stronger, time must flow more slowly. In regions where space-time is less curved, where gravity is weaker, time must flow more quickly. This prediction seemed almost too strange to be true. How could something as fundamental as time itself be affected by the presence of matter? How could the ticking of a clock depend on where that clock was located? Yet Einstein's equations were clear. Gravity doesn't just affect the motion of objects through space, it affects the flow of time itself. The implications of this discovery were staggering. It meant that time is not the universal constant that humans had always assumed it to be. Instead, time is local, personal, intimately connected to your position in the gravitational field around you. Two identical clocks, placed at different heights in a gravitational field, would tick at different rates. The clock closer to the source of gravity would tick more slowly, while the clock farther from the source would tick more quickly. This is precisely what creates the effect we explored in our first chapter. Your head, being slightly farther from the center of the Earth than your feet, experiences a slightly weaker gravitational field. As a result, time flows just a tiny bit faster at the level of your head than it does at the level of your feet. This difference accumulates over time, making your head age just a little bit more quickly than your feet. Einstein's theory also predicted other remarkable effects. Light traveling upward in a gravitational field would lose energy and shift toward the red end of the spectrum. Light traveling downward would gain energy and shift toward the blue end. This gravitational redshift and blue shift would become crucial tools for testing Einstein's theory and exploring the nature of gravity itself. The beauty of Einstein's insight lies not just in its mathematical elegance, but in its profound implications for our understanding of reality. It revealed that the universe is far more interconnected than we had ever imagined. Space and time are not separate stages upon which the drama of existence unfolds. Instead, they are active participants in that drama, responsive to the presence of matter and energy, flexible and dynamic. As you rest there now, breathing quietly in the gentle darkness, you are experiencing the direct consequences of Einstein's revolutionary insight. The space-time around you is curved by the mass of the Earth beneath you, creating the gravitational field that keeps you grounded. This curvature affects not just your motion through space, but your motion through time as well. Every breath you take is a breath taken in curved space-time. Every heartbeat is a heartbeat measured by clocks that tick at slightly different rates depending on their position in the gravitational field. The very atoms that make up your body are vibrating at frequencies that are subtly influenced by their position in the curved space-time around our planet. Einstein's theory also revealed something profound about the nature of acceleration. When you're in an elevator that suddenly starts moving upward, you feel pressed against the floor. Einstein realized that this feeling is indistinguishable from the feeling of increased gravity. If the elevator were accelerating upward at exactly the same rate as Earth's gravitational acceleration, you would feel twice as heavy as normal. This equivalence between gravity and acceleration means that whenever you accelerate, whether you're in a car speeding up, an airplane taking off, or simply walking up a flight of stairs, you're creating temporary changes in the flow of time around you. These changes are typically too small to measure with ordinary instruments, but they're real, and they add another layer of complexity to the temporal landscape we inhabit. The more Einstein explored these ideas, the more he realized that our everyday intuitions about space and time are fundamentally incorrect. We tend to think of space as a fixed container in which events occur, and time as a universal river flowing at a constant rate. But Einstein showed us that space and time are more like partners in a cosmic dance, each affecting the other, both responding to the presence of matter and energy. This dance creates a universe that is far more dynamic and interconnected than we might have imagined. Every object in the universe, from the smallest atom to the largest galaxy, participates in this dance. Every movement of matter, every flow of energy, every interaction between particles contributes to the ongoing choreography of space-time itself. As Einstein developed his theory, he began to realize that it could explain phenomena that had puzzled astronomers for centuries. The orbit of Mercury, for example, had a slight precession that couldn't be explained by Newton's theory of gravity alone. But Einstein's general relativity predicted exactly the amount of precession that was observed, providing one of the first confirmations of his revolutionary ideas. The theory also predicted the existence of gravitational waves, ripples in the fabric of space-time itself that would travel at the speed of light. These waves would be created whenever massive objects accelerate, such as when two black holes orbit each other and eventually merge. For decades, these waves remained purely theoretical, but in 2015, scientists finally detected them directly, using incredibly sensitive instruments called LIGO detectors. Einstein's quiet revolution also opened up new possibilities for understanding the cosmos. His equation suggested that the universe itself might be expanding or contracting, a prediction that initially seemed so strange that Einstein tried to modify his theory to prevent it. But observations eventually confirmed that the universe is indeed expanding, and Einstein's original equations, unmodified, describe this expansion perfectly. The implications of Einstein's discoveries continue to ripple through our understanding of the universe today. They've led to the prediction and discovery of black holes, regions of space-time where gravity is so strong that not even light can escape. They've helped us understand the behavior of neutron stars, objects so dense that a teaspoon of their material would weigh as much as a mountain. They've guided our exploration of the cosmos, from the smallest scales of quantum mechanics to the largest scales of cosmology. But perhaps most importantly for our gentle exploration tonight, Einstein's theory revealed that we live in a universe where time itself is an active participant in the cosmic dance. Time is not a passive backdrop against which events unfold. Instead, it's a dynamic, responsive aspect of reality that changes based on where you are and what's happening around you. This understanding adds a profound dimension to our appreciation of existence itself. As you lie there, feeling the gentle pull of gravity holding you to the earth, you're also feeling the gentle pull of time, flowing at its own rate based on your position in the curved space-time around our planet. You're not just a body moving through space. You're a temporal being, experiencing the flow of time in all its subtle complexity. The atoms in your body, the air in your lungs, the light reaching your eyes, all of these are participating in the same cosmic dance that Einstein first glimpsed over a century ago. They're all moving through curved space-time, all experiencing the effects of gravity on the flow of time itself. Einstein's insights also reveal something beautiful about the nature of measurement and observation. When we measure time, we're not measuring some abstract, universal quantity. We're measuring the local flow of time in our particular region of space-time. When we observe the universe around us, we're seeing events that occurred in the past, carried to us by light that has traveled through the curved space-time between us and distant objects. This creates a universe where observation and reality are intimately connected. The act of measurement becomes a way of exploring the local structure of space-time itself. Every clock is a probe of the gravitational field around it. Every beam of light is a messenger carrying information about the curvature of space-time through which it has traveled. As you rest there in the quiet darkness, you might find it comforting to know that Einstein's revolutionary insights emerged not from dramatic experiments or sudden revelations, but from quiet contemplation and careful thinking. He spent years pondering the implications of simple observations, following logical chains of reasoning to their inevitable conclusions. His approach was remarkably similar to what we're doing tonight, taking time to carefully consider the deeper implications of phenomena that surround us every day. The gravity that keeps your feet on the ground, the light that illuminates your room, the passage of time that carries you from one moment to the next. These are all aspects of a single, unified picture of reality that Einstein helped us discover. The revolution Einstein began continues today as scientists use his insights to explore ever more exotic aspects of the universe. We've discovered that space and time can be stretched and compressed by gravitational waves. We've found that near black holes, time can slow down so dramatically that what seems like minutes to someone falling would appear as hours or even years to someone watching from a safe distance. Yet at its heart, Einstein's theory remains beautifully simple. It's based on the idea that the laws of physics should be the same for all observers, regardless of their motion or their position in a gravitational field. This principle of general covariance, as it's called, leads directly to the conclusion that space-time must be curved by the presence of matter and energy. As we continue our gentle exploration tonight, we'll discover how scientists have tested and confirmed Einstein's predictions with ever-increasing precision. We'll explore how his insights apply to the world around us, from the atomic scale to the cosmic scale. But for now, simply rest in the knowledge that you are living in a universe far more beautiful and interconnected than our ancestors could have imagined. The quiet revolution that began in Einstein's mind over a century ago continues to unfold around us every day. It's present in the GPS satellites that help us navigate, which must account for the effects of gravity on time to provide accurate positions. It's present in the particle accelerators that probe the fundamental structure of matter, where Einstein's equation E equals mc squared governs the conversion between mass and energy. It's present in the observations of distant galaxies, where the curvature of space-time by intervening matter acts as a gravitational lens, magnifying and distorting the light from objects billions of light years away. And it's present in this very moment, as you lie there experiencing the gentle flow of time in Earth's gravitational field. Your head continuing its infinitesimal journey into the future, your feet following just a heartbeat behind, both carried forward by the cosmic dance of spacetime itself. Einstein's quiet revolution lives on in every moment of your existence, a testament to the power of careful thought and the beauty of the universe we inhabit. As you continue to rest there, breathing softly in the gentle darkness, let me tell you about one of the most elegant experiments ever conceived to test Einstein's remarkable predictions. It's a story that begins with a simple question. If time really does flow at different rates at different heights, how could we possibly measure something so incredibly subtle? The answer came from the most precise timekeepers humanity had ever created: atomic clocks. These remarkable devices don't rely on pendulums or springs or any mechanical mechanism. Instead, they count the vibrations of atoms themselves, using the natural frequency at which electrons dance around atomic nuclei as their timekeeper. The vibrations are so regular, so precise, that the best atomic clocks can measure time to within a few billionths of a second over the course of an entire year. In the 1970s, physicists realized they finally had instruments sensitive enough to detect the tiny time differences that Einstein's theory predicted. They could place identical atomic clocks at different heights and see whether time really does flow more slowly closer to the Earth's surface and more quickly farther away from it. The experiment they designed was beautifully simple in concept. They would place one atomic clock at the bottom of a tall building or tower and another identical clock at the top. According to Einstein's theory, the clock at the top, being slightly farther from the Earth's center and therefore in a slightly weaker gravitational field, should tick faster than the clock at the bottom. The difference would be incredibly small, just a few parts in a trillion, but it should be measurable with the most precise atomic clocks. Picture, if you will, a quiet university campus on a clear morning. The sun is just beginning to cast long shadows across the quadrangle, and the air is still and peaceful. Rising from the center of the campus is a tall clock tower, its weathered brick walls having stood for decades, marking the passage of time for generations of students and faculty. Today, this tower would become a laboratory for exploring one of the most profound mysteries in physics. The physicists begin their preparation with the kind of meticulous care that such a delicate experiment demands. They have two atomic clocks, each about the size of a large suitcase, filled with cesium atoms that will serve as their temporal measuring devices. These clocks are so accurate that they would need to run for millions of years before they would gain or lose even a single second. The first clock is carefully positioned at the base of the tower, perhaps in a temperature-controlled room where the vibrations from passing traffic and the fluctuations in air temperature can be minimized. The second clock makes a more dramatic journey, carried carefully up the winding stairs of the tower to a room near the top, perhaps 200 feet above its companion. As the experiment begins, both clocks are synchronized to tick in perfect harmony. For the moment, they agree completely about the passage of time. Each cesium atom in each clock vibrates at exactly the same frequency, creating identical rhythms that mark the flow of seconds, minutes, and hours. But as the hours pass, something remarkable begins to happen. The atomic clock at the top of the tower, experiencing a slightly weaker gravitational field than its companion below, begins to tick just a tiny bit faster. The difference is so small that it would take sophisticated electronic equipment to detect it, but it's there, real and measurable. After running for several days, the clocks show a tiny but unmistakable difference. The clock at the top of the tower has gained just a few billionths of a second compared to the clock at the bottom. This minuscule difference represents one of the most profound confirmations of Einstein's theory ever achieved. Direct evidence that time itself flows at different rates in different gravitational fields. The implications of this simple experiment ripple outward like gentle waves on a still pond. It means that every tall building is a time machine of sorts, with the upper floors existing in a slightly different temporal realm than the lower floors. It means that people who live in high-rise apartments are aging just a tiny bit faster than people who live in ground-floor homes. It means that the water in your body, as it flows from your heart to your head and back again, is traveling through regions where time passes at subtly different rates. But the beauty of this experiment extends beyond just confirming Einstein's predictions. It opened up entirely new ways of thinking about measurement and precision. The atomic clocks used in these experiments are so sensitive that they can detect changes in height of just a few inches. Move an atomic clock from the floor to a table, and it will immediately begin ticking at a measurably different rate. This extraordinary sensitivity has led to remarkable applications. Scientists have used atomic clocks to measure the shape of the Earth's gravitational field with unprecedented precision. They've discovered that the gravitational field is not perfectly uniform. It varies slightly from place to place depending on the density of the rock beneath your feet, the height of nearby mountains, and even the movement of groundwater far below the surface. In one particularly elegant experiment, researchers used atomic clocks to study the movement of magma deep beneath an active volcano. As the molten rock shifted and flowed in underground chambers, it created tiny changes in the local gravitational field. These changes were so small that they couldn't be detected by conventional instruments, but they were large enough to affect the flow of time itself, and atomic clocks could measure these temporal variations with extraordinary precision. The clock tower experiments also revealed something beautiful about the nature of scientific measurement. When we measure time, we're not measuring some abstract, universal quantity. We're measuring the local flow of time in our particular region of spacetime. Every measurement is, in a sense, a measurement of the gravitational field around us. This has led to a new field called relativistic geodesy, where scientists use the flow of time itself to map the gravitational field of the Earth. By precisely measuring how time passes at different locations around the globe, they can create incredibly detailed maps of our planet's gravitational landscape. These maps reveal the hidden structure of the Earth's interior, showing where dense rock formations lie deep beneath the surface and where lighter materials create regions of slightly weaker gravity. As you rest there now, you might find it comforting to know that these experiments have been repeated countless times in countless locations with increasingly sophisticated equipment. Each time, the results confirm Einstein's predictions with remarkable precision. The flow of time really does depend on your position in a gravitational field, and atomic clocks can measure these variations with extraordinary accuracy. The tower experiments have also been extended to much greater heights. Scientists have flown atomic clocks in airplanes, carrying them to altitudes of 30,000 feet or more. At these heights, the difference in the flow of time becomes more pronounced. A clock at cruising altitude gains about 4 millionths of a second per day compared to a clock on the ground. This might seem like a tiny amount, but it's easily measurable with modern atomic clocks. Even more dramatically, atomic clocks have been carried into space aboard satellites and space stations. At the altitude of the International Space Station, roughly 250 miles above the Earth's surface, time flows noticeably faster than it does on the ground. An astronaut spending 6 months on the space station will return to Earth having aged about 0.01 seconds more than they would have if they had stayed on the ground. This effect becomes even more pronounced for satellites in higher orbits. The GPS satellites that help us navigate on Earth orbit at an altitude of about 12,000 miles, where the gravitational field is significantly weaker than at the Earth's surface. As a result, time passes about 45 microseconds per day faster on these satellites than it does on the ground. This might not sound like much, but it has profound practical implications. The GPS system works by precisely timing signals from multiple satellites to determine your exact position. If the clocks on these satellites weren't corrected for the effects of gravity on time, the system would accumulate errors of several miles per day. Every time you use GPS to navigate, you're relying on Einstein's insights about gravity and time. The clock tower experiments have also been miniaturized and refined over the decades. Modern atomic clocks are so precise that they can detect the gravitational time dilation effect over height differences of just a few feet. Researchers have built atomic clocks that can measure the difference in the flow of time between your head and your feet, confirming directly that your head is indeed aging faster than your feet. One particularly elegant version of this experiment involved atomic clocks placed on different floors of a multi-story building. Even with just a few floors of height difference, the clocks showed measurable differences in their ticking rates. The clock on the upper floor consistently ran faster than the clock on the lower floor by exactly the amount that Einstein's theory predicted. These experiments have revealed something profound about the nature of time itself. Time is not a river flowing uniformly throughout the universe. Instead, it's more like a landscape with hills and valleys where the flow varies depending on your location. Every point in space has its own local flow of time, and these flows are all interconnected in a complex web of temporal relationships. The precision of modern atomic clocks has also allowed scientists to test Einstein's theory in increasingly extreme conditions. They've used clocks to study the effects of motion on time, confirming that time slows down for objects moving at high speeds. They've used clocks to study the effects of rotation, showing that time flows differently in different parts of a spinning system. As you lie there in the gentle darkness, you might imagine yourself as part of one of these experiments. Your body is like a collection of atomic clocks, each atom vibrating at its own frequency, each experiencing the flow of time in its own way. The atoms in your head are ticking just a little bit faster than the atoms in your feet, creating a subtle temporal gradient that runs through your entire body. This gradient is so gentle that you can't feel it directly, but it's there, real and measurable. It's part of the fundamental structure of the universe, part of the way that space and time respond to the presence of matter and energy. Every breath you take, every heartbeat, every moment of consciousness is shaped by this subtle dance between gravity and time. The clock tower experiments have also opened up new possibilities for exploring the nature of gravity itself. By measuring the flow of time with extraordinary precision, scientists can probe the gravitational field in ways that were never before possible. They can look for tiny variations in gravity that might reveal the presence of dark matter or dark energy, the mysterious components that make up most of the universe, but remain largely invisible to conventional observation. Some researchers have even proposed using atomic clocks as a new kind of telescope, one that looks not at light from distant objects, but the gravitational effects of those objects on the flow of time itself. This gravitational time telescope could potentially reveal phenomena that are completely invisible to conventional observation, opening up entirely new ways of exploring the cosmos. The beauty of the clock tower experiments lies not just in their confirmation of Einstein's predictions, but in their revelation of the intimate connection between measurement and reality. When we measure time, we're not just recording the passage of moments. We're probing the very fabric of space-time itself, exploring the hidden structure of the universe through the subtle variations in the flow of time. As we continue our gentle exploration tonight, we'll discover how these insights apply to the world around us, from the atomic scale to the cosmic scale. But for now, simply rest in the knowledge that you are living in a universe where time itself is an active participant in the cosmic dance. Every moment of your existence is shaped by the gravitational field around you. Every breath you take occurs in the curved space-time that surrounds our planet. The clock tower experiments have given us a new way of seeing the world, one where every height difference is a temporal difference, where every gravitational field is a landscape of time. They've shown us that the universe is far more interconnected than we ever imagined, where the flow of time in one location is intimately connected to the flow of time everywhere else. And they've given us tools of extraordinary precision, atomic clocks that can measure the passage of time with an accuracy that would have been unimaginable just a few decades ago. These tools continue to reveal new secrets about the nature of reality, new ways of understanding the deep structure of the universe we inhabit. As you rest there, feeling the gentle pull of gravity holding you to the earth, you're also experiencing the gentle variations in the flow of time that these experiments have revealed. You're part of a cosmic laboratory, a living experiment in the relationship between gravity and time. And that, perhaps, is one of the most remarkable things of all, that we can understand these subtle effects, measure them with extraordinary precision, and use them to explore the deepest mysteries of existence itself. Now, as you lie there in the gentle embrace of gravity, let me invite you to turn your attention inward to the remarkable temporal landscape that exists within your own body. We've explored how scientists measure time dilation in tall towers and with atomic clocks, but the most intimate example of this phenomenon is happening right now, in this very moment, as you breathe quietly and listen to these words. Your body is approximately 6 feet tall, give or take a few inches, which means there's a difference of about 6 feet between your head and your feet. In the grand scheme of the universe, this might seem like an insignificant distance, but in the delicate mathematics of Einstein's relativity, this small difference creates a measurable gradient in the flow of time itself. Let's begin this gentle exploration at the very top of your head. Right now, the hair follicles on your scalp are experiencing time at a rate that's just slightly faster than any other part of your body. The difference is extraordinarily small. We're talking about billionths of a second over the course of an entire day. But it's real, and it's been accumulating throughout your entire life. Picture, if you will, the individual atoms that make up the keratin in your hair. These atoms, carbon and sulfur and nitrogen, are all vibrating at their characteristic frequencies, all participating in the biochemical processes that keep your hair growing and healthy. But because they're at the highest point of your body, they're experiencing the weakest gravitational field you'll encounter, and therefore time passes just a tiny bit more quickly for them. Moving down just a few inches, we encounter the remarkable complexity of your brain. Here, billions of neurons are firing in intricate patterns, creating the thoughts and consciousness that allow you to understand these very words. The electrical impulses traveling through your neural networks are moving through regions of space-time, where time flows at subtly different rates depending on their exact position within your skull. The blood vessels in your brain carry oxygen and nutrients through this temporal landscape, with the circulation at the top of your brain moving through time at a pace that's infinitesimally faster than the circulation at the base of your brain. The cerebrospinal fluid that cushions your brain and spinal cord is flowing through a gravitational gradient, each molecule of this protective fluid experiencing time at a rate that depends on its precise location within your cranium. Your eyes, those remarkable organs that process light and create your vision of the world, are positioned at a height where time flows at a rate that's just slightly different from the rate at the back of your head. The photons entering your retina, the electrical signals traveling along your optic nerves, the processing that occurs in your visual cortex. All of these are happening within the gentle temporal gradient created by Earth's gravitational field. As we move down to your neck and shoulders, we encounter the incredible complexity of your circulatory system. Your heart pumps blood up to your brain through arteries that climb through regions where time flows at varying rates. The blood cells themselves are tiny temporal travelers, ascending through your carotid arteries into regions where time passes more quickly, then descending through your jugular veins back to regions where time passes more slowly. Your heart itself, that faithful organ that has been beating since before you were born, exists in a gravitational field that's slightly stronger than the field at your head, but slightly weaker than the field at your feet. Each heartbeat occurs at a rate that's influenced by this position. Each pulse of blood is timed by a cardiac rhythm that's synchronized with a local flow of time. The lungs that fill and empty with each breath are positioned at a height where time flows at its own particular rate. The oxygen molecules that enter your bloodstream in your lungs are joining a circulation system that will carry them through regions of varying temporal flow. Some will travel up to your brain, entering regions where time passes more quickly. Others will travel down to your legs and feet, entering regions where time passes more slowly. Your spine, that remarkable column of bone and cartilage that supports your entire body, creates a kind of temporal highway running from your head to your feet. The nerve impulses that travel up and down your spinal cord are moving through a gravitational gradient, with signals traveling from your feet to your brain moving from regions of slower time to regions of faster time, while signals traveling from your brain to your feet move from regions of faster time to regions of slower time. The muscles in your torso, your arms, your legs, are all positioned at different heights and therefore experience time at subtly different rates. The biochemical processes that power muscle contraction, the flow of calcium ions that trigger muscle fibers, the production of ADP that provides energy for cellular processes, all of these are occurring within the gentle temporal landscape created by your position in Earth's gravitational field. Your digestive system presents a particularly interesting case study in temporal variation. The food you eat begins its journey in your mouth, where it's positioned at a height where time flows relatively quickly. As it travels down your esophagus and into your stomach, it's moving into regions where time flows progressively more slowly. The nutrients absorbed in your intestines are entering your bloodstream at a height where time has a different flow rate than at your head or your feet. The water in your body, which makes up about 60% of your total mass, is constantly cycling through this temporal landscape. Water molecules absorbed in your digestive system flow through your bloodstream, some traveling up to your brain where they experience faster time, others traveling down to your extremities where they experience slower time. When you perspire, you're losing water molecules that have experienced time at rates that depend on where in your body they've been circulating. Your kidneys, those remarkable organs that filter your blood and regulate the water balance in your body, are positioned at a height where time flows at a rate that's intermediate between your head and your feet. The urine they produce carries with it the temporal signature of the height at which it was created, though this signature is far too subtle for us to detect with current technology. Even your skeleton participates in this temporal dance. The calcium atoms in your bones are continuously being remodeled, with old bone tissue being broken down and new bone tissue being built up. This process occurs at rates that are influenced by the local flow of time, with the bones in your skull experiencing time at a slightly different rate than the bones in your pelvis or your feet. The remarkable thing about this personal time gradient is that it's not just a mathematical curiosity, it's a fundamental aspect of your existence. Every biological process in your body, from the firing of neurons to the beating of your heart to the replication of DNA, is occurring within this temporal landscape. The fact that you function as a unified, coherent organism despite these tiny variations in the flow of time is a testament to the remarkable adaptability of biological systems. Your immune system, that complex network of cells and proteins that protects you from disease, operates throughout this temporal gradient. White blood cells traveling through your bloodstream move between regions where time flows at different rates. The antibodies produced by your immune system are created at one height and may travel to fight infections at other heights, crossing temporal boundaries that are invisible to us but real nonetheless. The hormones produced by your endocrine system tell a similar story. Hormones produced by your pituitary gland, located in your brain, are created in a region where time flows relatively quickly. These hormones travel through your bloodstream to target organs throughout your body, some at higher positions where time flows more quickly, others at lower positions where time flows more slowly. Your nervous system, that incredible network that processes information and coordinates your body's responses, operates across this entire temporal gradient. Nerve impulses traveling from your brain to your toes are moving from regions of faster time to regions of slower time. The reverse is true for sensory information traveling from your feet to your brain. These signals are moving from regions of slower time to regions of faster time. The temperature regulation system in your body also operates within this temporal landscape. The hypothalamus in your brain, which controls your body temperature, is positioned in a region where time flows relatively quickly. The sweat glands in your skin, which help cool your body, are distributed across regions where time flows at different rates depending on their height above the ground. As you breathe quietly now, you might imagine the air molecules entering your lungs, each one carrying with it the temporal signature of the height at which it was when you inhaled. The oxygen that reaches the alveoli in your lungs is entering your bloodstream at a specific height in Earth's gravitational field, and therefore at a specific rate of temporal flow. The carbon dioxide that you exhale carries with it the temporal history of its journey through your body. It might have been produced by cellular respiration in your brain, where time flows relatively quickly, or in your leg muscles, where time flows relatively slowly. All of these molecules converge in your lungs before being exhaled into the atmosphere. mixing their diverse temporal experiences into the air around you. Your sense of balance, controlled by the vestibular system in your inner ear, operates within this temporal gradient. The fluid in your semicircular canals, which helps you maintain your orientation and balance, is positioned at a height where time flows at a rate that's different from the rate at your feet. This system has evolved to function perfectly within the gravitational field of Earth, including the subtle temporal variations that field creates. The growth and repair processes that occur throughout your body are also influenced by this temporal landscape. The stem cells that generate new tissue, the proteins that repair damaged cells, the DNA replication that occurs during cell division. All of these processes are happening within the gentle time gradient that runs from your head to your feet. Your body's circadian rhythms, the internal biological clocks that regulate your sleep-wake cycle, and many other physiological processes operate within this temporal framework. The suprachiasmatic nucleus in your brain, which acts as your body's master clock, is positioned in a region where time flows at a rate that's different from other parts of your body. Yet somehow, your body maintains coherent biological rhythms despite these subtle temporal variations. The aging process itself takes on new meaning when viewed through this temporal lens. While the difference in aging rate between your head and your feet is far too small to have any practical biological significance, it's a reminder that aging is fundamentally a temporal process, and that process is subtly influenced by your position in Earth's gravitational field. Even your dreams, those mysterious mental experiences that occur during sleep, are taking place within this temporal landscape. The neural activity that creates your dreams is occurring in your brain, where time flows at a rate that's slightly different from the rate at other parts of your body. Your dream experiences are shaped by electrical and chemical processes that are all influenced by the local flow of time. The remarkable adaptability of life becomes even more impressive when we consider that biological systems evolved within this temporal gradient. Every organism on Earth, from the simplest bacteria to the most complex mammals, has evolved to function within the gravitational field of our planet, including the subtle temporal variations that field creates. Your personal time gradient is also constantly changing, though in ways that are too subtle for you to notice. When you stand up, you're redistributing your mass vertically, creating tiny changes in the gravitational field around you, and therefore tiny changes in the flow of time. When you lie down, as you're doing now, you're creating a different configuration of mass, and therefore a different temporal landscape. The water you drink, the food you eat, even the air you breathe, all contribute to the total mass of your body and therefore to the gravitational field you create. These changes are incredibly small, but they're real, and they create subtle fluctuations in the temporal environment around you. As you rest there in the gentle darkness, you might find it comforting to know that this personal time gradient is part of what makes you unique. No two people have exactly the same height, the same mass distribution, the same position in Earth's gravitational field. Each person carries their own, slightly different temporal signature, their own personal relationship with the flow of time. This temporal uniqueness extends to every moment of your life. Your exact position, your posture, your breathing, your heartbeat, all of these create a temporal landscape that's uniquely yours. You're not just a biological organism moving through space. You're a temporal being, creating and experiencing your own personal flow of time with every breath, every heartbeat, every moment of consciousness. The gentle gradient of time that runs through your body is a reminder of the profound interconnectedness of all existence. You're not separate from the universe around you. You're an integral part of the cosmic dance of spacetime itself. Every atom in your body, every biological process, every moment of consciousness is shaped by the same fundamental forces that govern the motion of planets and the evolution of galaxies. As we continue our gentle exploration tonight, we'll discover how this personal time gradient connects to the larger temporal landscape of our planet and our cosmos. But for now, simply rest in the knowledge that you are a temporal being, living in a universe where time itself is flexible, responsive, and intimately connected to the very fabric of reality. your head continuing its infinitesimal journey into the future, your feet following just a heartbeat behind, both carried forward by the gentle, eternal dance of gravity and time. Now, as you rest there with a deeper understanding of your own temporal landscape, let me invite you to journey with me into an even more intimate realm, the world of atoms themselves. For it's at this smallest scale of matter that we can truly appreciate the profound whispers of time dilation, where individual atoms experience the gentle pull of gravity on time in ways that reveal the deepest secrets of existence itself. Picture, if you will, a single atom of carbon residing in a cell in your brain. This atom, like all atoms, is in constant motion, its electrons orbiting the nucleus in patterns that have remained unchanged for billions of years. But this atomic dance is not occurring in some abstract, timeless void. It's happening in the curved space-time around our planet, where the flow of time itself is influenced by Earth's gravitational field. The frequency at which this carbon atom's electrons orbit their nucleus is so precise, so regular, that it can serve as a natural clock. In fact, this is exactly how atomic clocks work. They count the vibrations of atoms to measure the passage of time with extraordinary accuracy. But what makes this particularly fascinating is that these atomic vibrations are themselves influenced by the gravitational field in which the atom resides. An atom of carbon in your brain, positioned roughly 6 feet above the ground, experiences a gravitational field that's slightly weaker than the field experienced by an identical carbon atom in your big toe. This means that the electrons in the brain atom orbit at a frequency that's just slightly higher than the frequency of the electrons in the toe atom. The difference is incredibly small. We're talking about changes of just a few parts in a trillion, but it's real, and it's measurable with the most sophisticated instruments. This atomic scale time dilation creates a universe where every atom carries its own temporal signature, its own personal relationship with the flow of time. The iron atoms in your blood, as they travel through your circulatory system, experience continuously changing rates of time as they move between different heights in your body. When they're pumped up to your brain, they enter a region where time flows just a little more quickly. When they circulate down to your feet, they enter a region where time flows just a little more slowly. The oxygen molecules you breathe tell a similar story. As they enter your lungs and dissolve into your bloodstream, they're entering a temporal landscape where their atomic vibrations are influenced by the local gravitational field. Some of these molecules will travel to your brain, where they'll experience time at a rate that's slightly faster than the rate they experienced in your lungs. Others will travel to your legs and feet, where they'll experience time at a rate that's slightly slower. What's particularly beautiful about this atomic perspective is that it reveals the continuity between the quantum world and the cosmic world. The same principles that govern the behavior of atoms also govern the behavior of planets, stars, and galaxies. The gravitational time dilation that affects atomic vibrations is the same phenomenon that affects the ticking of clocks, the aging of organisms, and the evolution of the universe itself. Consider the calcium atoms in your bones. These atoms have been part of your skeleton for years, slowly being replaced as part of the natural process of bone remodeling. Throughout their residence in your bones, they've been experiencing time at a rate that depends on their exact position in your body. The calcium atoms in your skull have been experiencing time at a slightly different rate than the calcium atoms in your pelvis or your feet. The phosphorus atoms that make up part of your DNA are particularly fascinating from this perspective. DNA replication, the process by which your cells copy their genetic information, occurs throughout your body. But the atomic processes that drive this replication are happening in gravitational fields of slightly different strengths. The DNA replication occurring in your brain cells happens in a region where time flows at a rate that's minutely different from the rate in your leg cells. This means that at the deepest level, even your genetic processes are influenced by your position in Earth's gravitational field. The molecular machinery that reads your DNA, the proteins that are synthesized based on genetic instructions, the cellular processes that repair damaged DNA, all of these are occurring within the gentle temporal gradient that runs through your body. The water molecules in your body provide another beautiful example of atomic scale time dilation. Water is constantly cycling through your system. You consume it in food and drink. It's used in countless biological processes, and it's eliminated through respiration, perspiration, and excretion. Throughout this cycle, each water molecule experiences time at rates that depend on its position in your body. A water molecule absorbed in your small intestine might travel through your bloodstream to your brain, where it experiences time at a rate that's slightly faster than the rate it experienced in your digestive system. Later, that same molecule might travel to your kidneys, where it experiences time at yet another rate. Eventually, it might be eliminated from your body through perspiration, carrying with it the temporal signature of its journey through your internal gravitational landscape. The sodium and potassium ions that are essential for nerve function also participate in this atomic scale temporal dance. These ions flow across cell membranes to create the electrical impulses that allow your nervous system to function. As they move through your body, they're constantly transitioning between regions where time flows at subtly different rates. The nerve impulses themselves, the electrical signals that carry information throughout your nervous system, are propagated by the movement of these ions across cell membranes. This means that the very mechanism by which your brain processes information is influenced by the gravitational time dilation that affects individual atoms and ions. The proteins in your body, those complex molecules that catalyze biochemical reactions and provide structural support, are made up of atoms that all experience time at rates that depend on their position in Earth's gravitational field. The amino acids that make up these proteins, the chemical bonds that hold them together, the three-dimensional structures they form, all of these are influenced by the local flow of time. Enzymes, the protein catalysts that speed up chemical reactions in your body, are particularly interesting from this perspective. The rate at which an enzyme catalyzes a reaction depends on the vibrations of the atoms within the enzyme molecule. These vibrations are influenced by the gravitational field in which the enzyme resides, which means that enzymatic activity is subtly influenced by gravitational time dilation. The hemoglobin molecules in your red blood cells carry oxygen from your lungs to tissues throughout your body. As these molecules travel through your circulatory system, they're constantly moving between regions where time flows at different rates. The oxygen-binding properties of hemoglobin depend on the precise arrangement of atoms within the molecule, and these arrangements are influenced by the local flow of time. Even more remarkably, the atomic clocks that scientists use to measure time dilation are based on the same principles that govern the behavior of atoms in your body. The cesium atoms in atomic clocks vibrate at frequencies that are influenced by the gravitational field around them, just like the atoms in your body. The difference is that atomic clocks are designed to measure these tiny variations, while your body has evolved to function seamlessly despite them. The carbon dioxide molecules that you exhale carry with them the atomic signatures of their production within your body. Some of these molecules were produced by cellular respiration in your brain, where they experience time at a rate that's slightly different from molecules produced by cellular respiration in your feet. All of these molecules converge in your lungs before being exhaled, mixing their diverse temporal experiences into the breath you release. The hormones produced by your endocrine system are made up of atoms that experience time at rates that depend on where in your body they're produced and where they travel. Insulin produced by your pancreas, growth hormone produced by your pituitary gland, adrenaline produced by your adrenal glands. All of these molecular messengers are composed of atoms that participate in the gravitational time dilation that affects your entire body. The neurotransmitters that allow your brain cells to communicate with each other are also subject to these atomic scale temporal effects. Dopamine, serotonin, acetylcholine, and other neurotransmitters are all composed of atoms that experience time at rates influenced by the gravitational field in your brain. The chemical reactions that produce these neurotransmitters, the processes that release them at synapses, and the mechanisms that break them down are all influenced by the local flow of time. The DNA in your cells contains the genetic instructions that guide all of your biological processes. But this DNA is made up of atoms, carbon, nitrogen, oxygen, phosphorus, and hydrogen, that all experience time at rates that depend on their position in your body. The double helix structure of DNA, the hydrogen bonds that hold the two strands together, the chemical processes that repair DNA damage, all of these are influenced by gravitational time dilation. The mitochondria in your cells, those cellular powerhouses that produce the energy your body needs to function, are filled with atoms that experience time at rates influenced by the gravitational field around them. The complex biochemical processes that occur within mitochondria, the production of ADP that powers cellular processes, the electron transport chains that drive cellular respiration, all of these are occurring within the gentle temporal landscape created by Earth's gravity. The lipids that make up your cell membranes are composed of atoms that experience time at rates that depend on their position in your body. These membranes separate the interior of your cells from the external environment, and they're constantly being maintained and repaired through processes that are influenced by the local flow of time. The minerals in your body, calcium, phosphorus, magnesium, iron, zinc, and many others, are all atoms that experience time at rates influenced by the gravitational field around them. These minerals are essential for countless biological processes, from bone formation to enzyme function to nerve transmission. All of these processes are occurring within the temporal landscape created by Earth's gravity. The fascinating thing about atomic scale time dilation is that it reveals the fundamental unity of all matter. Every atom in your body, regardless of what element it is or what molecule it's part of, participates in the same cosmic dance of gravity and time. The carbon in your muscles, the oxygen in your lungs, the calcium in your bones, they're all subject to the same fundamental laws that govern the behavior of matter throughout the universe. This atomic perspective also reveals the incredible precision of the natural world. The fact that your body functions as a coherent, unified system despite the tiny temporal variations that affect individual atoms is a testament to the remarkable robustness of biological systems. Life has evolved to function within the gravitational field of Earth, including all of the subtle temporal effects that field creates. The quantum mechanical properties of atoms are also influenced by gravitational time dilation. The energy levels of electrons in atoms, the frequencies at which they absorb and emit light, the chemical bonds they form, all of these are subtly influenced by the gravitational field in which the atoms reside. This creates a universe where quantum mechanics and general relativity are intimately connected, where the smallest scales of matter are influenced by the largest scales of space-time. As you rest there now, breathing quietly in the gentle darkness, you might imagine the trillions of atoms in your body, each one participating in this cosmic dance of time and gravity. Each atom carries its own temporal signature, its own personal relationship with the flow of time. Yet somehow, all of these atoms work together to create the unified experience of being you. The breath you're taking right now involves the coordinated movement of countless atoms and molecules, all experiencing time at rates that depend on their position in your body. The oxygen entering your lungs, the carbon dioxide being removed, the hemoglobin molecules carrying gases through your bloodstream. All of these processes are occurring within the gentle temporal gradient that runs through your body. Your heartbeat, that steady rhythm that has been with you since before you were born, is created by the coordinated movement of atoms and molecules in your cardiac muscle. The calcium ions that trigger muscle contraction, the ADP molecules that provide energy, the proteins that generate force. All of these are experiencing time at rates influenced by the gravitational field around your heart. The thoughts you're having as you listen to these words are created by the movement of atoms and molecules in your brain. The neurons that fire to process information, the neurotransmitters that carry signals between cells, the glucose molecules that provide energy for brain function. All of these are experiencing time at rates that are slightly different from the rates experienced by atoms in other parts of your body. This atomic perspective reveals that you are not just a biological organism. You are a cosmic entity, intimately connected to the fundamental structure of space-time itself. Every atom in your body carries the signature of its journey through the gravitational field of Earth. Every biological process in your body is influenced by the curvature of space-time around our planet. The remarkable thing is that this has been true throughout the entire history of life on Earth. Every organism that has ever lived, from the first simple bacteria to the most complex mammals, has existed within this temporal landscape. Evolution has shaped life to function within the gravitational field of our planet, including all of the subtle temporal effects that field creates. As we continue our gentle exploration tonight, we'll discover how this atomic-scale understanding of time dilation connects to the larger scales of our planet and our cosmos. But for now, simply rest in the knowledge that you are composed of atoms that are all participating in the cosmic dance of gravity and time. Each atom in your body is a tiny temporal being, experiencing the flow of time in its own unique way, yet all working together to create the unified experience of your existence. The whispers of time dilation that we can detect in atomic clocks are the same whispers that affect every atom in your body. You are not separate from the universe. You are made of the same stuff as stars and planets, subject to the same fundamental laws, participating in the same cosmic dance of spacetime. And in this moment, as you rest and listen and breathe, you are experiencing the profound interconnectedness of all existence, from the smallest atom to the largest galaxy, all united in the gentle, eternal flow of time itself. Now, as you rest there with a deeper understanding of how time flows through your own body and the atoms that compose you, let me invite you to expand your awareness outward to the vast and varied landscape of our planet Earth. For just as your body contains its own temporal gradient, our entire world is sculpted by the gentle influence of gravity on time, creating a rich tapestry of temporal variation that spans from the highest mountain peaks to the deepest ocean trenches. Imagine, if you will, that you could see time itself as a visible landscape flowing like a vast, invisible river across the surface of our planet. This temporal topography would reveal peaks and valleys, gentle slopes and sudden drops, all shaped by the distribution of mass within the Earth and the varying strength of gravity from place to place. Let's begin our journey at the highest point on our planet, the summit of Mount Everest, reaching 29,032 feet above sea level. Here, in the thin air and bitter cold of the world's highest peak, time flows at a rate that's measurably faster than it does at sea level. A climber standing on the summit of Everest is experiencing time at a rate that's about 80 microseconds per day faster than someone standing at the beach. Picture a lone mountaineer, having spent weeks climbing through the death zone, finally reaching the summit as the sun rises over the curvature of the Earth. In this moment of triumph, as they stand at the highest point on our planet, they're also standing at a place where time itself flows more quickly than almost anywhere else on Earth's surface. The atoms in their body, the beating of their heart, the firing of neurons in their brain, all of these are occurring in a region where time has been liberated just slightly from gravity's grip. The snow crystals beneath their feet, each one a perfect hexagonal masterpiece formed in the thin atmosphere, are experiencing time at this accelerated rate. The ice that has accumulated over centuries on Everest's summit has been aging at a pace that's infinitesimally faster than ice at sea level. The very rocks that form a mountain's peak, thrust upward by the collision of tectonic plates millions of years ago, have been experiencing time at rates that depend on their elevation. As we descend from Everest's summit, we encounter the temporal landscape of the world's other great peaks. The Andes Mountains, stretching along the western edge of South America, create a spine of faster-flowing time through the continent. The Himalayas, that great wall of stone and ice that separates the Indian subcontinent from the Tibetan Plateau, form a region where time flows more quickly than in the lower elevations that surround them. The Rocky Mountains of North America, the Alps of Europe, the Urals of Russia, all of these mountain ranges create local variations in the flow of time. A hiker walking from a valley to a mountain peak is not just changing elevation, they're climbing through a gradient of time itself, moving from regions where time flows more slowly to regions where time flows more quickly. But mountains don't just create faster flowing time at their peaks. They also create complex temporal landscapes in their valleys and foothills. The mass of a mountain range creates gravitational effects that extend far beyond the visible peaks. The granite and basalt and limestone that compose these mountains all contribute to the local gravitational field, creating subtle variations in the flow of time throughout the surrounding region. Consider the Great Rift Valley of Africa, that massive geological feature that stretches from the Red Sea to Mozambique. This valley, formed by the gradual separation of tectonic plates, creates a depression in the Earth's surface where time flows slightly more slowly than in the elevated regions that surround it. The animals that migrate through this valley, the wildebeest, the zebras, the gazelles, are all experiencing time at a rate that's subtly different from the rate experienced by animals in the surrounding highlands. The temporal effects of topography become even more interesting when we consider the massive ice sheets that cover parts of our planet. The Greenland ice sheet, containing enough ice to raise global sea levels by over 20 feet if it were to melt completely, creates a significant gravitational anomaly. The sheer mass of this ice, accumulated over thousands of years, creates a region where gravity is slightly stronger than normal, and therefore where time flows slightly more slowly. The Antarctic ice sheet, even more massive than Greenland's, creates an even more pronounced gravitational effect. The ice that covers Antarctica contains about 70% of the world's fresh water, and this enormous mass creates a region where time flows noticeably more slowly than it does in other parts of the world. A penguin waddling across the Antarctic ice is experiencing time at a rate that's measurably different from a bird flying over the tropical oceans. These ice sheets also create what scientists call post-glacial rebound, where land that was compressed by the weight of ice during previous ice ages is still slowly rising. This ongoing geological process creates continuously changing gravitational fields, and therefore continuously changing rates of time flow. The land itself is participating in a slow-motion dance of temporal variation. The ocean depths present us with some of the most dramatic temporal variations on our planet. The Mariana Trench, the deepest part of the world's oceans, plunges to a depth of over 36,000 feet below sea level. At the bottom of this trench, time flows at a rate that's measurably slower than at the ocean's surface. The bizarre creatures that live in these depths, the anglerfish with their bioluminescent lures, the giant tube worms that cluster around hydrothermal vents, are all experiencing time at a rate that's different from creatures living in shallow waters. The pressure at these depths is extraordinary, over 1,000 times greater than at sea level. But it's not just the pressure that creates a different environment. It's also the flow of time itself. Water molecules at the bottom of the ocean are experiencing time at a rate that's slower than water molecules at the surface. This creates a kind of temporal stratification in the ocean, with different depths experiencing different rates of time flow. The mid-ocean ridges, where new oceanic crust is formed as tectonic plates separate, create underwater mountain ranges that stretch for thousands of miles. These ridges create local variations in the gravitational field, and therefore local variations in the flow of time. The volcanic activity at these ridges, the formation of new rock from molten magma, the creation of new seafloor, all of these processes are occurring within the varied temporal landscape of the ocean depths. The great ocean currents that circulate around our planet carry water through regions where time flows at different rates. The Gulf Stream, that massive current that brings warm water from the Gulf of Mexico to the North Atlantic, carries water molecules through a journey that includes variations in the flow of time. As the current moves over underwater mountains and valleys, through regions of different gravitational strength, it's carrying water through a temporal landscape as complex as any terrestrial topography. The seasonal variations in Earth's mass distribution also create temporal effects. When winter arrives in the northern hemisphere, billions of tons of water are locked up in snow and ice. This redistribution of mass creates subtle changes in the gravitational field, and therefore subtle changes in the flow of time. The snow that falls on a winter morning is participating in a global redistribution of mass that affects the temporal landscape of the entire planet. The great rivers of the world, the Amazon, the Nile, the Mississippi, the Yangtze, all flow through gravitational landscapes that create variations in the flow of time. The water in these rivers is constantly changing elevation as it flows toward the sea, moving through regions where time flows at different rates. The sediment carried by these rivers, the nutrients they transport, the life they support, all of these are participating in journeys through time as well as space. The Amazon rainforest, often called the lungs of the Earth, creates its own unique temporal environment. The massive amounts of water vapor that the forest releases into the atmosphere, the carbon dioxide it absorbs, the oxygen it produces, all of these processes are occurring within the gentle temporal variations created by the forest's elevation and the distribution of its mass. The seasonal flooding of the Amazon basin creates dramatic changes in the local gravitational field. When the rains come and vast areas of forest are inundated with water, the additional mass of the floodwater creates regions where time flows more slowly. When the floods recede, the gravitational field returns to its previous state, and the flow of time returns to its previous rate. The great deserts of the world, the Sahara, the Gobi, the Atacama, present their own temporal characteristics. The sand dunes that shift with the wind are constantly redistributing mass, creating subtle changes in the local gravitational field. The underground water reserves that sustain oases in these deserts exist in regions where time flows at rates that depend on their depth below the surface. The volcanic islands scattered throughout the world's oceans create dramatic local variations in the flow of time. The Hawaiian island chain, formed by volcanic activity over a hot spot in the Earth's mantle, creates a series of gravitational anomalies in the middle of the Pacific Ocean. The mass of these islands, built up over millions of years by countless volcanic eruptions, creates regions where time flows more slowly than in the surrounding ocean. The seasonal migrations of animals add another layer of complexity to the temporal landscape of our planet. The Arctic tern, which migrates from Arctic to Antarctic and back each year, experiences dramatic variations in the flow of time as it travels from the high latitudes to the equator and back. The whales that migrate between feeding and breeding grounds are traveling through ocean regions where time flows at different rates. Even the atmosphere itself participates in this temporal dance. The jet streams that circle the globe at high altitudes are regions where time flows more quickly than at sea level. Commercial aircraft flying at cruising altitude are traveling through regions where time flows at a measurably different rate than on the ground. The pilots and passengers on these flights are experiencing time at a rate that's faster than people on the surface below. The aurora borealis and aurora australis, those spectacular displays of light that occur near the poles, are created by interactions between solar particles and the Earth's magnetic field. These interactions occur at altitudes where time flows more quickly than at the surface, creating light shows that are literally illuminated by faster flowing time. The seasonal changes in vegetation also create temporal effects. When forests leaf out in spring, they're adding mass to the elevated regions where they grow. When leaves fall in autumn, they're redistributing this mass back to the ground. These seasonal changes in the distribution of biomass create subtle variations in the gravitational field, and therefore subtle variations in the flow of time. The great coral reefs of the world, those underwater gardens that support an incredible diversity of marine life, exist in regions where time flows at rates that depend on their depth below the ocean surface. The Great Barrier Reef, stretching for over 1,400 miles along the coast of Australia, creates a vast underwater landscape where time flows at different rates depending on the depth of the water. The polar ice caps, those vast sheets of ice that cover the Arctic Ocean and the continent of Antarctica, create some of the most dramatic gravitational effects on our planet. The Arctic ice cap, floating on the ocean, creates a different gravitational signature than the Antarctic ice cap, which rests on solid ground. Both create regions where time flows more slowly than in ice-free regions. The Great Lakes of the world, Lake Superior, Lake Baikal, the Caspian Sea, contain massive amounts of water that create local gravitational effects. The water in these lakes is experiencing time at a rate that's influenced by its depth below the surface and its elevation above sea level. The fish that swim in these lakes, the birds that fly over them, the people who live along their shores, all are experiencing time at rates that are influenced by the presence of these massive bodies of water. The underground cave systems that exist throughout the world create their own temporal environments. The Mammoth Cave system in Kentucky, the Carlsbad Caverns in New Mexico, the vast limestone caves of the Yucatan Peninsula, all of these underground spaces exist in regions where time flows at rates that depend on their depth below the surface. As you rest there now, perhaps you can imagine yourself as a traveler moving through this vast temporal landscape of our planet. If you could journey from the deepest ocean trenches to the highest mountain peaks, you will be traveling through a range of temporal variation that spans several microseconds per day. You would be moving through regions where time flows at dramatically different rates, where the very atoms in your body would experience the passage of time in subtly different ways. The remarkable thing about this planetary temporal landscape is that it's not static. It's constantly changing as ice melts and refreezes, as tides rise and fall, as the seasons change and redistribute mass around the globe. The Earth itself is a dynamic temporal entity, constantly reshaping the flow of time through the movement of matter and energy. The weather patterns that sweep across our planet also create temporal effects. A massive storm system, with its associated changes in atmospheric pressure and the movement of vast amounts of water vapor, creates temporary changes in the local gravitational field. The eye of a hurricane, with its dramatically reduced atmospheric pressure, creates a region where time flows at a rate that's subtly different from the surrounding areas. The great mountain ranges continue to grow and change, thrust upward by the collision of tectonic plates and worn down by the forces of erosion. As these mountains rise and fall over geological time, they create continuously changing gravitational fields and therefore continuously changing rates of time flow. The very landscape of our planet is participating in a slow dance of temporal variation that has been ongoing for billions of years. This planetary perspective reveals that the temporal gradient running through your body is just one small part of a vast, interconnected system of temporal variation that spans the entire Earth. The difference between your head and your feet is connected to the difference between mountain peaks and ocean depths, between polar ice caps and tropical rainforests, between the deepest caves and the highest clouds. As we continue our gentle exploration tonight, we'll discover how this planetary temporal landscape connects to even larger scales, to the movement of satellites in orbit, to the flow of time throughout our solar system, and ultimately to the cosmic dance of space-time itself. But for now, simply rest in the knowledge that you are part of a planet that is itself a temporal entity, where every mountain and valley, every ocean and continent, every forest and desert participates in the gentle, eternal flow of time shaped by the distribution of mass and the pull of gravity. The Earth beneath you is not just a solid foundation. It's a dynamic participant in the cosmic dance of space-time, constantly reshaping the flow of time through the movement of continents, the melting of ice, the circulation of oceans, and the growth of mountains. And you, resting there in this moment, are part of this vast temporal symphony, connected to every atom in every mountain peak and every drop of water in every ocean depth, all united in the gentle, flowing dance of time itself. Now, as you rest there with a deeper understanding of how time flows across our planet's varied landscape, let me invite you to journey upward with me, beyond the atmosphere, into the realm of satellites that orbit our Earth. For it's in this space, high above the surface of our planet, that we encounter some of the most dramatic and practically important examples of gravitational time dilation, effects that have become essential to our modern way of life. Picture, if you will, a clear night sky filled with stars. But scattered among those ancient points of light are newer, artificial stars, the satellites that humanity has launched into orbit around our planet. These satellites, invisible to the naked eye but constantly present overhead, are experiencing time in ways that would have seemed like pure science fiction just a few decades ago. The Global Positioning System, or GPS, represents one of the most remarkable applications of Einstein's insights about gravity and time. This constellation of satellites, orbiting about 12,000 miles above the Earth's surface, must account for the effects of time dilation in order to provide the accurate positioning information that we've come to depend on in our daily lives. Each GPS satellite carries with it several atomic clocks, some of the most precise time-keeping devices ever created. These clocks tick with extraordinary accuracy, losing or gaining less than 1 second in millions of years. But despite their precision, these clocks are experiencing time at a rate that's measurably different from clocks on the Earth's surface. At the altitude where GPS satellites orbit, the gravitational field is significantly weaker than at the Earth's surface. This means that time flows faster for the satellites than it does for us on the ground. The difference is about 45 microseconds per day, a tiny amount, but one that would render the GPS system completely useless if it weren't corrected. Imagine a GPS satellite passing silently overhead as you rest there. This satellite, about the size of a car and weighing roughly 2,000 pounds, is traveling at a speed of about 8,700 miles per hour. As it orbits the Earth, it's constantly broadcasting precise time signals, each one stamped with the exact moment it was transmitted according to the satellite's atomic clocks. But here's where Einstein's insights become crucial. The satellite's clocks are ticking faster than clocks on the ground. If this difference weren't corrected, the GPS system would accumulate errors of about 6 miles per day. Your smartphone's map application, which relies on GPS for positioning, would quickly become useless without these relativistic corrections. The engineers who designed the GPS system had to account for 2 different relativistic effects. First, there's the gravitational time dilation we've been exploring, the fact that time flows faster in weaker gravitational fields. Second, there's the special relativistic effect of motion, the fact that time flows slower for objects moving at high speeds. The satellites are moving fast enough that this second effect also becomes significant. The gravitational effect dominates, causing the satellite clocks to run fast, while the motion effect causes them to run slow. The net result is that the satellite clocks run about 38 microseconds per day faster than clocks on the ground. This might seem like a trivial amount, but it's enough to make GPS completely unreliable without correction. The beautiful thing about GPS is that it has made Einstein's theory of relativity part of our everyday lives. Every time you use your phone to navigate to a restaurant, every time you call for a ride-sharing service, every time you check your location on a map, you're relying on precise corrections for the effects of gravity and motion on the flow of time. But GPS satellites are just one example of how objects at different altitudes experience time differently. The International Space Station, orbiting at an altitude of about 250 miles, experiences time at a rate that's about 25 microseconds per day faster than on Earth's surface. The astronauts who live and work on the space station are literally traveling through time at a rate that's different from people on the ground. An astronaut who spends 6 months on the International Space Station will return to Earth having experienced time at a rate that's about 4 milliseconds faster than people on the ground. This means that the astronaut will have aged about 4 milliseconds more than their Earthbound colleagues during their mission. It's a tiny difference, but it's real and measurable. The communications satellites that enable our global telecommunications networks are positioned even higher, in geostationary orbit about 22,000 miles above the Earth's surface. At this altitude, the gravitational field is much weaker than at the Earth's surface, and time flows significantly faster. The electronic systems in these satellites must account for these temporal effects to maintain accurate communication links. Weather satellites, Earth observation satellites, and scientific research satellites all orbit at various altitudes, each experiencing time at its own rate, depending on its position in Earth's gravitational field. The data they collect, the images they capture, and the measurements they make are all time-stamped using clocks that are running at rates different from clocks on the ground. The Hubble Space Telescope, orbiting at an altitude of about 340 miles, experiences time at a rate that's about 30 microseconds per day faster than on Earth's surface. The incredible images of distant galaxies and nebulae that Hubble captures are all time-stamped using clocks that are running slightly fast compared to clocks on the ground. The light from ancient stars and galaxies, carrying information about the early universe, is recorded by instruments that are themselves experiencing time at an accelerated rate. Even more dramatically, satellites in highly elliptical orbits experience continuously changing rates of time flow as they move closer to and farther from the Earth. A satellite in a highly elliptical orbit might experience time flowing at one rate when it's at its closest approach to Earth, and at a significantly different rate when it's at its farthest point. The effects of time dilation on satellites also create interesting challenges for mission planning. When engineers design satellite missions, they must account for the fact that the satellite's clocks will be running at a different rate than clocks on the ground. This affects everything from data transmission schedules to the timing of orbital maneuvers. The atomic clocks aboard satellites are not just passive timekeepers. They're active participants in a global network of time synchronization. Ground-based atomic clocks, satellite-based atomic clocks, and the various corrections applied to account for relativistic effects all work together to create a unified global time standard that account for the effects of gravity and motion on the flow of time. The deep space missions that explore the outer reaches of our solar system experience even more dramatic time dilation effects. The Voyager spacecraft, launched in the 1970s and now traveling through interstellar space, are experiencing time at rates that are different from clocks on Earth. The radio signals they send back to Earth carry timestamps that reflect their journey through regions where time flows at different rates. The New Horizons mission, which flew by Pluto in 2015, traveled through regions of our solar system where the sun's gravitational field has different effects on the flow of time. The images and data it collected were all time-stamped using clocks that were experiencing time at rates that varied depending on the spacecraft's position in the solar system. The Mars rovers, Curiosity, Perseverance, and their predecessors are operating on a planet where time flows at a rate that's different from Earth. Mars is farther from the Sun than Earth, so the solar gravitational field is weaker there. Additionally, Mars has less mass than Earth, so its own gravitational field is weaker. These factors combine to create a planet where time flows at a rate that's subtly different from the rate on Earth. The precise timing required for communicating with these distant spacecraft must account for the effects of time dilation. When mission controllers on Earth send commands to a Mars rover, they must account for the fact that the rover's clocks are running at a slightly different rate than clocks on Earth. The round-trip time for radio signals between Earth and Mars varies, depending on the positions of the planets, but it's also affected by the relativistic effects of motion and gravity. The European Space Agency's Rosetta mission, which studied Comet 67P/Churyumov-Gerasimenko, traveled through regions of the solar system where time flows at different rates depending on the distance from the Sun and the speed of the spacecraft. The data collected by Rosetta about the composition and behavior of the comet were all time-stamped using clocks that were experiencing time at rates that varied throughout the mission. The James Webb Space Telescope, positioned at the L2 Lagrange point about 1 million miles from Earth, experiences time at a rate that's different from both Earth and the satellites in Earth orbit. This position, where the gravitational forces of the Earth and Sun balance out, creates a unique temporal environment where the telescope's instruments can make observations of the distant universe. The effects of time dilation on satellites also have implications for the synchronization of global networks. The Internet, global financial systems, and international communications all rely on precise time synchronization. The atomic clocks aboard satellites play a crucial role in maintaining this synchronization, but they must be constantly corrected for the effects of relativity. The military applications of satellite technology also depend on precise timing that accounts for relativistic effects. Military GPS receivers, secure communication systems, and navigation equipment all rely on timing that's been corrected for the effects of gravity and motion on the flow of time. The commercial satellite industry has grown to encompass everything from television broadcasting to internet services to Earth observation. All of these applications depend on precise timing that accounts for the effects of time dilation. The satellites that provide internet access to remote areas, the satellites that broadcast television signals, and to satellites that provide navigation services all carry atomic clocks that are experiencing time at rates different from clocks on the ground. The future of satellite technology promises even more dramatic examples of time dilation effects. Proposed missions to the outer planets, to the moons of Jupiter and Saturn, and eventually to other star systems will encounter gravitational environments where time flows at rates that are dramatically different from Earth. The concept of a solar system-wide internet, with communication relays positioned throughout the solar system, will require unprecedented precision in timing synchronization. The effects of time dilation will become even more important as we expand our presence beyond Earth orbit. As you rest there now, you might look up at the night sky and imagine the invisible constellation of satellites orbiting overhead. Each one is a small temporal island, experiencing time at its own rate, carrying atomic clocks that tick at frequencies different from clocks on the ground. These satellites are constantly broadcasting time signals, sending down streams of precisely timed information that enable our modern technological civilization. The GPS receiver in your phone, if it's nearby, is at this very moment receiving signals from multiple satellites, each one time-stamped with atomic precision but corrected for the effects of relativity. The calculation of your position depends on measuring the tiny differences in the arrival times of these signals, differences that are measured in billionths of a second. The weather forecast you might check tomorrow will be based on data collected by satellites that are experiencing time at rates different from clocks on the ground. The satellite images that show cloud formations, storm systems, and weather patterns are all time-stamped using clocks that are running fast compared to terrestrial clocks. The International Space Station, if it's currently passing overhead, is carrying astronauts who are experiencing time at a rate that's slightly faster than you are. Their biological processes, their scientific experiments, and their daily routines are all occurring in a temporal environment that's subtly different from the one you're experiencing. The remarkable thing about satellite-based time dilation is that it's not just a theoretical curiosity. It's a practical necessity that enables much of our modern technology. Without accounting for the effects of gravity and motion on the flow of time, our satellite-based systems would quickly become useless. GPS would fail, communications would be disrupted, and our ability to navigate and communicate across the globe would be severely compromised. The engineers and scientists who design and operate these satellite systems have made Einstein's theory of relativity an essential part of our technological infrastructure. Every GPS satellite, every communication satellite, every weather satellite is a testament to the practical importance of understanding how gravity affects the flow of time. The precision required for these systems is extraordinary. The timing corrections applied to satellite clocks must be accurate to within nanoseconds, billionths of a second. This level of precision requires a deep understanding of relativistic physics and sophisticated computer algorithms that continuously calculate and apply the necessary corrections. The global network of satellite systems creates a kind of temporal grid that spans the entire Earth. This grid consists of thousands of atomic clocks, each one experiencing time at its own rate, but all synchronized through careful application of relativistic corrections. The result is a unified global time standard that accounts for the effects of gravity and motion on the flow of time. The satellite industry continues to push the boundaries of what's possible with precise timing. New generations of atomic clocks are being developed that will be even more accurate than current systems. These clocks will enable new applications that require unprecedented precision in timing and positioning. The study of time dilation effects on satellites has also led to new insights about the nature of spacetime itself. By carefully measuring the effects of gravity and motion on satellite clocks, scientists have been able to test Einstein's theory of relativity with extraordinary precision. These tests have confirmed the theory's predictions and have helped us understand the fundamental nature of space and time. As we continue our gentle exploration tonight, we'll discover how these satellite-based examples of time dilation connect to even larger scales, to the flow of time throughout our solar system and beyond. But for now, simply rest in the knowledge that above you, invisible in the night sky, a constellation of satellites is experiencing time at rates different from your own, each one carrying atomic clocks that tick to the rhythm of Einstein's cosmic dance. The next time you use GPS to navigate, the next time you check satellite weather data, the next time you communicate via satellite, you'll be relying on technology that depends on a precise understanding of how gravity affects the flow of time. You'll be participating in a global network of temporal synchronization that spans from the Earth's surface to the edge of space, all united in the gentle, precise dance of relativistic time correction. The satellites overhead are not just technological marvels, they're temporal laboratories, constantly demonstrating the reality of Einstein's insights about the nature of space and time. They're proof that we live in a universe where time is not absolute, where the flow of time depends on where you are and how fast you're moving, where the practical applications of theoretical physics have become essential to our daily lives. And as you rest there, breathing quietly in the gentle darkness, you're connected to this vast network of temporal technology, part of a global system that spans from the deepest ocean trenches to the highest satellite orbits, all synchronized through the careful application of our understanding of gravity's effect on the flow of time itself. Now, as you rest there with a deeper understanding of how time flows differently across our planet and beyond, let me invite you to contemplate one of the most profound implications of Einstein's discovery, that we are all, in every moment of our lives, living in multiple times simultaneously. This isn't just a poetic metaphor. It's a literal description of the reality we inhabit, where every breath you take, every heartbeat, every thought occurs across a landscape of temporal variation that spans from the quantum to the cosmic. Picture, if you will, this very moment as you listen to these words. You might think of it as a single, unified instant, the present moment that contains your consciousness, your breathing, your awareness of these ideas. But the reality is far more beautiful and complex. This moment is actually composed of countless individual moments, each occurring at slightly different rates, depending on their position in the gravitational field around you. The air molecules entering your lungs right now are experiencing time at rates that vary depending on their altitude. Some entered at the level of your nose and mouth, others at the level of your chest as it expands. These molecules, identical in every way except for their position, are participating in the same breath but experiencing time at subtly different rates. The blood cells flowing through your circulatory system are living in a temporal landscape that changes with every heartbeat. As your heart pumps blood upward toward your brain, those cells are moving into regions where time flows more quickly. As they return through your veins, they're moving into regions where time flows more slowly. Each blood cell is a tiny temporal traveler, experiencing the passage of time at rates that vary continuously throughout its journey. The neurons firing in your brain as you process these words are positioned at different heights within your skull, each one experiencing time at its own infinitesimal rate. The electrical impulses that create your thoughts, the chemical reactions that power your consciousness, the synaptic connections that form memories, all of these are occurring across a gradient of temporal variation that spans the few inches between the top and bottom of your brain. Your DNA, that remarkable molecule that carries the instructions for your entire being, exists in cells throughout your body, each copy experiencing time at a rate that depends on its position in Earth's gravitational field. The DNA in your brain cells experiences time at a rate that's slightly different from the DNA in your heart cells, which is different from the DNA in your feet. Yet somehow, all of these copies work together to create the unified being that is you. The water in your body, constantly cycling through your system, carries with it a temporal history that reflects its journey through your internal landscape. A water molecule absorbed in your digestive system might travel to your brain, where it experiences faster time, then to your kidneys, where it experiences a different rate, then to your skin, where it might be eliminated through perspiration. Each molecule carries the temporal signature of its journey through your body. The calcium atoms in your bones have been residing in your skeleton for months or years, experiencing time at rates that depend on their exact position in your body. The calcium in your skull has been aging at a rate that's slightly different from the calcium in your pelvis or your feet. These atoms, identical in every way except for their position, accumulate slightly different amounts of temporal experience over the course of their residence in your body. The air in the room around you creates its own temporal landscape. The molecules near the ceiling are experiencing time at a rate that's slightly faster than the molecules near the floor. The difference is incredibly small, but it's real. The sound waves carrying these words to your ears are traveling through air that has its own subtle temporal variations, creating a three-dimensional landscape of slightly different time rates. The light illuminating your surroundings, whether it's artificial light from a lamp or natural light from the moon and stars, is traveling through this same temporal landscape. Photons of light moving upward through the room are gaining energy and shifting slightly toward the blue end of the spectrum, while photons moving downward are losing energy and shifting slightly toward the red end. The light itself is participating in the gravitational dance of time and space. The building or room you're in creates its own gravitational field, though incredibly weak compared to Earth's. The mass of the walls, the floor, the ceiling, and everything in the room contributes to the local gravitational environment. This means that the flow of time in your room is subtly different from what it would be in an empty space at the same location. The objects around you, furniture, books, electronics, clothing, all contribute to the local distribution of mass and therefore to the local gravitational field. A heavy bookshelf creates a tiny gravitational effect that influences the flow of time in its immediate vicinity. The effect is far too small to measure with any practical instrument, but it's real nonetheless. The people in your life, your family and friends, are all experiencing their own personal temporal landscapes. When you're together in the same room, you're sharing a temporal environment, but each person's individual height and mass distribution creates their own unique relationship with the flow of time. When you embrace someone, you're literally bringing your temporal landscapes together, creating a shared moment that occurs across multiple rates of time flow. The pets in your household, if you have any, are living in their own temporal worlds. A cat sleeping on a high shelf is experiencing time at a rate that's slightly different from a dog lying on the floor. The difference is negligible, but it's part of the rich tapestry of temporal variation that exists in every household. The plants in your home or garden are experiencing time at rates that depend on their height and position. A tall houseplant has leaves that are aging at rates that depend on their height above the ground. The roots, buried in soil, are experiencing time at a rate that's different from the leaves reaching toward the light. Over the course of a plant's lifetime, these tiny differences in temporal experience accumulate, though they're far too small to have any practical effect on the plant's growth or health. The seasonal changes that occur throughout the year create variations in your temporal environment. In winter, when snow accumulates on the ground, the additional mass creates regions where time flows slightly more slowly. In summer, when the snow melts and the water evaporates or flows away, the gravitational field returns to its previous state. These seasonal changes in the distribution of mass create subtle variations in the flow of time that occur on a yearly cycle. The weather patterns that move through your area also create temporal effects. A massive storm system, with its associated changes in atmospheric pressure and the movement of water vapor, creates temporary variations in the local gravitational field. The passage of a storm front creates a moving region where time flows at rates that are subtly different from the surrounding areas. The tides caused by the gravitational pull of the moon and sun create cyclic variations in the distribution of water around the Earth. These tidal movements create subtle changes in the local gravitational field that affect the flow of time. During high tide, the additional water mass creates regions where time flows slightly more slowly. During low tide, the reduced water mass allows time to flow slightly more quickly. The phases of the moon create variations in the tidal forces that affect the distribution of water on Earth. During a full moon or new moon, when the sun and moon are aligned, the tidal forces are stronger, creating more dramatic variations in the distribution of water and therefore in the flow of time. During the quarter moon phases, the tidal forces are weaker, creating smaller variations in the temporal landscape. The orbital motion of the Earth around the Sun creates another layer of temporal complexity. As the Earth moves through its elliptical orbit, the distance from the Sun varies throughout the year. This variation in solar distance creates subtle changes in the Sun's gravitational effect on the flow of time. The difference is incredibly small, but it's part of the complex temporal environment in which we live. The rotation of the Earth on its axis creates centrifugal forces that vary with latitude. These forces create subtle variations in the effective gravitational field that affect the flow of time. Time flows slightly differently at the equator than at the poles, not just because of the difference in distance from the Earth's center, but also because of the effects of the Earth's rotation. The precession of the Earth's axis, that slow wobble that occurs over thousands of years, creates long-term variations in the gravitational environment. These variations are incredibly slow and subtle, but they're part of the complex temporal landscape that has existed throughout human history. The movement of the solar system through the galaxy creates even larger-scale temporal effects. As our solar system orbits the center of the Milky Way galaxy, it moves through regions where the gravitational field varies depending on the distribution of stars and dark matter. These variations are incredibly subtle, but they're part of the cosmic temporal environment in which our planet exists. The expansion of the universe itself creates temporal effects on the largest scales. The stretching of space that occurs as the universe expands affects the flow of time in ways that are still being studied and understood by cosmologists. We are living in a universe that is not only expanding in space, but also evolving in time, creating a temporal landscape that spans from the quantum to the cosmic. The gravitational waves that ripple through space-time, created by the collision of black holes and neutron stars in distant galaxies, pass through our local region of space and create tiny, temporary variations in the flow of time. These waves, detected by incredibly sensitive instruments like LIGO, are evidence of the dynamic nature of space-time itself. The dark matter that makes up most of the mass in the universe creates gravitational effects that influence the flow of time, even though we can't see or directly detect this matter. The dark matter halo that surrounds our galaxy creates a gravitational environment that affects the flow of time throughout the Milky Way. The life cycles of stars in our galaxy create temporal effects that span millions and billions of years. When a massive star explodes as a supernova, it creates gravitational waves that ripple through space-time and temporarily affect the flow of time in the surrounding region. When stars are born in stellar nurseries, the concentration of matter creates regions where time flows more slowly than in the empty regions between stars. The black holes that exist throughout the universe create some of the most extreme temporal effects known to physics. Near a black hole, time can slow down so dramatically that what seems like minutes to someone falling in would appear as hours or even years to someone watching from a safe distance. These extreme temporal effects are part of the larger tapestry of time dilation that exists throughout the universe. The cosmic microwave background, the afterglow of the Big Bang that fills the universe, carries with it information about the temporal structure of the early universe. This radiation, which has been traveling through space for nearly 14 billion years, has been affected by the gravitational fields of all the matter it has encountered on its journey. The multiverse, if it exists, would create temporal effects on scales that are difficult to imagine. Different regions of the multiverse might have different physical laws, different rates of time flow, different relationships between space and time. We might be living in just one small region of a vast temporal landscape that spans multiple universes. The quantum mechanical effects that occur at the smallest scales create their own temporal complexities. The uncertainty principle, which governs the behavior of particles at the quantum level, creates fluctuations in the flow of time that occur on incredibly small scales. These quantum temporal effects are part of the overall temporal landscape in which we exist. The virtual particles that pop into existence and disappear again in the quantum vacuum create tiny temporal disturbances that affect the flow of time on the smallest scales. These effects are far too small to detect directly, but they're part of the quantum foundation upon which the larger temporal effects we've been exploring are built. As you rest there now, breathing quietly in the gentle darkness, you might imagine yourself as a conscious being existing simultaneously across all of these temporal scales. You are living in the quantum temporal fluctuations of the vacuum, in the atomic temporal variations within your body, in the gravitational temporal landscape of the Earth, in the orbital temporal cycles of the solar system, in the galactic temporal environment of the Milky Way, and in the cosmic temporal evolution of the universe itself. Every moment of your existence spans multiple rates of time flow, from the fastest quantum fluctuations to the slowest cosmic evolution. You are not just living in time. You are living in multiple times simultaneously, each one real, each one contributing to the rich temporal tapestry of your existence. The remarkable thing about living in multiple times is that it reveals the profound interconnectedness of all existence. The quantum effects that occur in the atoms of your body are connected to the cosmic effects that occur in distant galaxies. The temporal landscape of your room is connected to the temporal landscape of the universe. Every moment of your life is part of a vast, interconnected web of temporal relationships that spans from the smallest to the largest scales of existence. This multiplicity of temporal experience is not something you can feel directly, but it's something you can contemplate and appreciate. It's part of the deep structure of reality, part of the beautiful complexity of the universe in which we live. It's a reminder that even in our most ordinary moments, we are part of something extraordinary, something that connects us to the deepest mysteries of space and time. As we continue our gentle exploration tonight, we'll discover how this multiplicity of temporal experience connects to the very largest scales of the universe. But for now, simply rest in the knowledge that you are living in multiple times simultaneously, experiencing the flow of time across scales that span from the quantum to the cosmic, all united in the gentle, eternal dance of existence itself. You are not just a single being living in a single moment. You are a multi-temporal entity, experiencing the rich complexity of time's flow across every scale of existence, from the smallest quantum fluctuations to the largest cosmic evolution. And in this recognition, you find yourself not separate from the universe, but intimately connected to its deepest temporal mysteries, part of the vast, beautiful, ever-flowing dance of time itself. Now, as you rest there with a deep understanding of your multi-temporal existence, let me invite you to expand your awareness one final time to the vast cosmic scales where time flows in rhythms that span billions of years. Here, in the gentle dance of galaxies and the patient evolution of the universe itself, we find the ultimate expression of time's flexibility, where the same principles that make your head age faster than your feet govern the destinies of stars and the fate of entire cosmic structures. Picture, if you will, our Milky Way galaxy as it slowly rotates through the cosmic night. This vast spiral of stars, gas, and dust, containing hundreds of billions of suns, creates a gravitational field so immense that it shapes the flow of time across distances that span tens of thousands of light years. Near the supermassive black hole at the galaxy's center, time flows more slowly than in the outer spiral arms where our solar system resides. The stars closest to the galactic center, those brilliant points of light that orbit the central black hole in elliptical paths, experience time dilation effects that are dramatic even by cosmic standards. As these stars approach their closest point to the black hole, time slows down so significantly that what appears to be a few days to the star might appear as weeks or months to an observer in the outer regions of the galaxy. Our own solar system, positioned in a quiet spiral arm about 26,000 light-years from the galactic center, exists in a region where time flows at a rate that's become our cosmic baseline. But even here, the distribution of matter creates subtle temporal variations. The asteroid belt, with its collection of rocky debris, creates regions where time flows at rates that are infinitesimally different from the empty space between the planets. Jupiter, with its massive gravitational field, creates a temporal environment around itself that's noticeably different from the rest of the solar system. The moons of Jupiter, Io, Europa, Ganymede, and Callisto each experience time at rates that depend on their distance from the giant planet. Europa, closest to Jupiter, experiences time at a rate that's measurably slower than Callisto, the outermost of the four large moons. The rings of Saturn, those beautiful bands of ice and rock that encircle the planet, create their own temporal landscape. The particles in the inner rings experience time at rates that are different from the particles in the outer rings. Over the millions of years that these rings have existed, these temporal differences have accumulated, though they're far too small to affect the dynamics of the ring system. The comets that visit our inner solar system from the distant Oort cloud carry with them the temporal signatures of their long journey. These ancient travelers, some of which have orbits that span thousands of years, experience dramatically different gravitational environments as they travel from the outer reaches of the solar system to their closest approach to the Sun. Beyond our solar system, the nearest stars create their own temporal environments. Alpha Centauri, our nearest stellar neighbor, creates a gravitational field that shapes the flow of time in its immediate vicinity. The planets that orbit other stars, those thousands of exoplanets that have been discovered in recent years, each exist in their own unique temporal landscapes shaped by the gravitational fields of their parent stars. The star-forming regions scattered throughout our galaxy, those vast nebulae where new stars are born, create temporal environments that are shaped by the concentration of matter and the intense gravitational fields of forming stars. The Orion Nebula, that beautiful stellar nursery visible to the naked eye, is a region where time flows at rates that vary depending on the local density of gas and dust. The red giant stars that represent the final stages of stellar evolution create temporal effects that span millions of years. As these stars expand and shed their outer layers, they create changing gravitational fields that affect the flow of time in their surrounding regions. The planetary nebulae that result from these stellar deaths are temporal artifacts, frozen moments in the evolution of spacetime itself. The white dwarf stars that represent the final fate of stars like our Sun create intense gravitational fields that dramatically affect the flow of time. Near the surface of a white dwarf, time flows at a rate that's significantly slower than in the surrounding space. These stellar remnants are like temporal beacons, marking regions where time has been slowed by the intense concentration of matter. The neutron stars, even more exotic stellar remnants, create some of the most extreme temporal effects in the universe. These incredibly dense objects, with masses greater than our Sun compressed into spheres just a few miles across, create gravitational fields so intense that time near their surfaces slows to a crawl compared to the surrounding space. The pulsars, rapidly rotating neutron stars that emit beams of radiation, create temporal effects that pulse in rhythm with their rotation. The lighthouse-like beams of radiation that sweep across space carry with them the temporal signatures of the intense gravitational fields from which they originate. The binary star systems, where two stars orbit around their common center of mass, create complex temporal environments that change as the stars move through their orbits. When the stars are closest together, the combined gravitational field creates regions where time flows more slowly. When they're farther apart, the temporal effects are less pronounced. The globular clusters, those ancient collections of stars that orbit our galaxy, create their own temporal landscapes. The stars in the dense centers of these clusters experience time at rates that are different from the stars in the outer regions. These differences, accumulated over the billions of years that these clusters have existed, are part of the temporal history of our galaxy. The dark matter that makes up most of the mass in the universe creates gravitational effects that influence the flow of time, even though we can't see this matter directly. The dark matter halo that surrounds our galaxy creates a subtle temporal environment that affects the flow of time throughout the Milky Way. The cosmic web, that vast network of filaments and voids that characterizes the large-scale structure of the universe, creates temporal variations on the largest scales. The dense filaments, where galaxies are concentrated, create regions where time flows more slowly than in the empty voids between them. The expansion of the universe itself creates temporal effects that span cosmic scales. As space expands, it affects the flow of time in ways that are still being studied and understood by cosmologists. The rate of expansion, described by the Hubble constant, is intimately connected to the temporal structure of the universe. The cosmic microwave background, that afterglow of the Big Bang that fills the universe, carries with it information about the temporal structure of the early universe. This radiation has been traveling through space for nearly 14 billion years, and its journey has been affected by the gravitational fields of all the matter it has encountered. The evolution of the universe itself can be understood as a temporal phenomenon. The formation of the first stars, the assembly of galaxies, the development of the cosmic web, all of these processes occur within the framework of spacetime, where the flow of time is shaped by the distribution of matter and energy. The future evolution of a universe will continue to be shaped by the relationship between gravity and time. As the universe continues to expand and cool, the temporal landscape will continue to evolve. The formation of new stars will create new temporal environments, while the death of old stars will eliminate others. As you rest there now, breathing quietly in the gentle darkness, you might imagine yourself as part of this vast cosmic temporal symphony. The same principles that create tiny time differences between your head and your feet also govern the flow of time around black holes, the evolution of galaxies, and the expansion of the universe itself. And so we come to the end of our gentle journey through the landscape of time, though in truth, this journey never really ends. As you rest there now, breathing slowly and peacefully, you carry with you a new understanding of the universe and your place within it. You are not just a collection of matter moving through space. You are a temporal being intimately connected to the deepest rhythms of existence itself. The tiny difference between your head and your feet that we explored at the beginning of our journey is just one note in a vast symphony of temporal variation that spans from the quantum to the cosmic. In this moment, as you prepare to drift into sleep, you are part of something far more beautiful and interconnected than you might have imagined. Your breath, slow and peaceful, carries with it the temporal signatures of its journey through your body. The air enters your lungs in regions where time flows at one rate, travels through your bloodstream to regions where time flows at another rate, and participates in the cellular processes that sustain your life across this gentle gradient of temporal variation. Your heartbeat, that faithful rhythm that has accompanied you throughout your life, creates its own temporal cadence. Each pulse sends blood through regions where time flows at subtly different rates, creating a circulation that is both spatial and temporal. Your heart is not just pumping blood through your body. It's orchestrating a dance of time itself. Your thoughts, as they drift towards sleep, are created by neural processes that occur across the temporal gradient within your brain. The very consciousness that allows you to understand these concepts is emerging from electrical and chemical processes that participate in the cosmic dance of gravity and time. As you settle deeper into rest, you might imagine yourself as a gentle traveler through the temporal landscape of existence. You are floating through time like a leaf on a stream, carried by currents that connect you to every other conscious being, every star, every galaxy in the universe. The darkness around you is not empty. It's filled with the invisible presence of time itself, flowing at its own gentle pace, shaped by the mass of the earth beneath you, influenced by the gravitational fields of the moon and sun, connected to the vast temporal web that spans the entire cosmos. Your body, relaxing as you drift towards sleep, is a small but significant part of this cosmic temporal symphony. Every atom in your body, every molecule, every cell participates in the same fundamental dance that governs the behavior of black holes and the evolution of galaxies. The pillow beneath your head, the blanket that covers you, the air that surrounds you, all of these are participating in the gentle flow of time that makes your head age just slightly faster than your feet. It's a reminder that even in our most ordinary moments, we are part of something extraordinary. As sleep approaches, you might feel a sense of peace in knowing that you are held not just by gravity, but by time itself. The universe is not a cold, empty void. It's a warm, interconnected web of temporal relationships that connects every point in space to every other point, every moment to every other moment. Your dreams, when they come, will occur in the same temporal landscape that we've explored tonight. The neural processes that create your dream experiences will participate in the same cosmic dance of gravity and time that shapes the evolution of stars and galaxies. And when you wake, you will carry with you this understanding that you're not separate from the universe, but intimately connected to its deepest structures. The difference between your head and your feet is a doorway into the profound mysteries of existence itself. Time is not just something that passes. It's something that flows, something that dances, something that connects us all in the gentle, eternal rhythm of existence. And you, resting there in this moment, are part of that rhythm, part of that dance, part of that eternal flow. As we end our journey together, I want to thank you for traveling with me through these cosmic landscapes of time. If you've enjoyed this exploration, please consider subscribing to Whispering Atom, and let me know in the comments where you are in the world and what time it is as you listen to these words. But for now, simply rest. Let yourself drift into sleep, knowing that you are held by the gentle embrace of time itself. Your head will continue its infinitesimal journey into the future. Your feet will follow just a heartbeat behind, and you will dream in the same temporal landscape that cradles every star, every planet, every conscious being in the universe. Sleep well, temporal traveler. Rest peacefully in the knowledge that you are part of something vast and beautiful and eternal. And dream sweetly of the gentle dance of time that connects you to everything that was, everything that is, and everything that ever will be. Sweet dreams and good night.